Welcome, everyone. We're excited to learn with you today. We'll wait a couple seconds as we can see people are logging in. So welcome to our session. I am Jody Garino and Sue Kim is here with me. And we work for the Orange County Department of Education and are excited to learn with you all today. In this session, we're going to be taking a look at how to extend children's natural curiosity through the use of same and different images that surface mathematical concepts. So we will be watching the brilliance of young students investigate tasks today. And we're going to be discussing how to elicit ideas that strategically push on student thinking to explore the development of reasoning and communication skills in math. So we're excited that you have joined us. So I want to give you a little bit of grounding for our session. So if you want to go to the next slide, grounding for our session, in some work that I did with a researcher named Chapina Rumsey, we spent 2 years following teachers in primary grades, kindergarten, first grade, and second grade, following teachers and students with mathematical argumentation. We recently wrote this book, Nurturing Math Curiosity with Learners in Grades K2. And we're going to start by creating an image of nurturing math curiosity of students in K2, and then think about the same and different routine that we'll be doing today and how that builds useful skills for young children as they progress to primary grades. So we're really thinking about the same and different work we're doing today as sort of a prequel for young children that can support them as they progress to kindergarten and second grade. So that is going to ground our work. And I invite you to read the quote on the slide here. This quote really resonated with us as we think about this idea that children enter this world as emergent mathematicians, naturally curious, especially Sue and I are both parents. And as we think about our children as they were young, always asking why and trying to make sense of things and the wonder. And then something happened, curious. And so we're really thinking about like, how can we nurture curiosity so that curiosity that kids are born with, that they come to us with, how do we support them to continue with that as they make sense of math and the world around them? So that really guides us, that quote. And now we're going to jump to the guiding principles that guide our work. So we believe that students bring curiosity, wonder, and intuitive knowledge to our classrooms. They know a lot before they get to us, right? And they bring this curiosity, and everyone in our classrooms, in our homes, in our spaces has important ideas to contribute. So we always want to keep that in mind, that it's not really learning just from the teacher, but really thinking about learning from each other, and everyone has really valuable ideas. We also believe that we can learn from each other, and it's important to value the knowledge and ideas within the community. So how do we create these spaces where kids really lean into each other's ideas and see value in it, and just this idea that we're all learning together? And also this idea that children need opportunities to learn how to communicate, both to speak with and listen to others. So as we're going through our session today, we really want to think about kids' communication and how we can support that. And we're talking about verbal communication, written communication, nonverbal communication, things like gesturing. How do we create lots of opportunities and space for kids to communicate both as listeners and as speakers? So now we're going to situate this work in a kindergarten lesson. This comes from a classroom in Southern California. The teacher's name was Bethany Lockhart Johnson, and she posed this question to her students, this story problem. So Mrs. Carino has 10 rabbits in her backyard. Sometimes the rabbits are in the hutch and sometimes out on the grass. Show the different ways the rabbits can be in the hutch and on the grass. So we invite you to pause for a minute and think about how might a kindergartner solve this problem? Or what have you seen students do in whatever grade levels or whatever age students you work with? I want to add a little bit of context to this. And I'm telling you this problem now, and you see the picture of the bunnies, a bunny and a hutch. And in a classroom, I would certainly do a lot of work unpacking and making sure kids know what is a hutch and providing visuals. Um, so for the sake of this today, I want you to just imagine how might a kindergartner or other students solve this. So as you think about that, you're welcome to put ideas in the chat, and I will stop talking for a minute to give you time to think. So I love seeing all of these ideas in the chat. We might see students drawing rabbits, having students use manipulatives maybe to put them onto the grass or into the hutch. Maybe we'd see students using 10 frames, whiteboards, lots of drawings, acting it out, certainly. I should have probably added this. When Bethany Lockhart Johnson gave this to her students, she had on a sheet of paper an image, and the image had a hutch like the hutch you see, and then a grassy area. So there were certainly a lot of kids that were moving like cubes or crayons that represented the rabbits in the different spaces on the grass, in the hutch. Um, Bethany's kindergarten class had, I don't know, maybe around 25 or 30 students. She had a class full of students, and they were all working at tables. And the tables were arranged so there were like 4 to 6 kids at a table. It certainly was not quiet. Kids were chatting and they were joyful. And as students were working, she was walking around. I too was walking around and just asking kids, like, oh, tell us about your thinking. There was lots of chatter going on in the room. A lot of kids found a way to do it. Like some kids would say like, oh, 5 can be in the grass. And because kids were sitting near each other and talking and being really social, other kids were like, oh, I thought about it as 9 and 1. Well, maybe there's 2 ways. So we started seeing multiple ways emerging as kids interacted with each other. And then Bethany walked over to Ava, and Ava was a student in her kindergarten class. And I want to show you the work, what was on Ava's paper when Bethany walked over to her. This is what was on her paper, along with the words, there are 11. So take a minute and make sense of Ava's work. What do you notice about Ava's work? And you're welcome to drop some thoughts into the chat. Ava was became the student teacher. Yeah, Ava was one of the kindergartners. I'm looking at Erica's mentioning that she started with one number and went up. Like she saw this pattern. Look at that. She started with 1 plus 9. And then went to 2 plus 8. We see this structure, and she's already thinking about numbers symbolically. And Marisol's noticed she saw patterns. Like these patterns are fascinating. It's also, Janet, as you're noticing, yeah, there are 11 possibilities. I found this one really interesting, right? That she started with 1 plus 9, and then she got to the end. Maybe this is how she did it. I didn't actually see her do it, and then added 0 plus 10. So what's fascinating is what happened after this. So this was on her paper when Bethany walked over. And here's what happened next. So this was on her paper. And so if you want, and Bethany asked her, well, how do you know she had all the ways? Because remember on the bottom, she wrote there are 11. And Ava said, I think I have all the ways and I have all the ways backward. And when Bethany asked her, what do you mean? She pointed at her paper and she showed, like, when I look at all this, I have 3 plus 7, and she pointed to that, and 7 plus 3. So the way she communicated was that all the ways backwards. So she noticed these patterns and the discussion continued. And Ava said, I noticed that it's the regular number, but one more. Like if I have 6, there are 7 different ways. And then Bethany posed the question to her, do you think that works for every number? And Ava said, I think it works for all the numbers to 20. So I want to give you a minute to think about like, wow, what's underneath that? What is she making sense of? How does she communicate? So take a minute and feel free to enter in the chat. What are you noticing about this interaction between Bethany and Ava? So I love this noticing, right? The commutative property. She's got this idea of, I've got them in even the backward ones. And Bethany's questions are certainly stretching her when she's saying like, tell me more about that. What do you mean by the word backward? Yeah. Right? Supporting Ava in her communication. But also this question, do you think that works for every number? And Ava's like, yeah, I think it works for all the numbers to 20, which is sort of this fascinating opportunity to nudge Ava a little bit more, but also thinking about like, wow, now she's thinking like it not only works for this, but for these other numbers. And even as she's saying, like, if I have 6, there are 7 different ways. Like, oh my gosh, Ava certainly has experience composing and decomposing numbers. And she is seeing and using the structure. And I want to pause. I think I sort of alluded to this, but not all kids were doing what Ava did. Certainly some kids were building one way and moving manipulative. So there was a wide range. But we just wanted to drop in and really think about like, okay, so what does it mean what Ava's doing? So if you want to go to the next slide, Sue. So Ava, her words were the regular number, but one more. So she was basically like conjecturing this idea that for any whole number n, there are n plus 1 ways to add 2 whole numbers. Really powerful and really thinking about what she did. And she told us there are 11 ways to make 10. And then in her discussion with Bethany, she also said, like the number 6, there are going to be 7 different ways to make the number 6. So she's generalizing it. And then later through questioning, she says, yeah, it might work for every number to 20. So she's really making this conjecture. And we wanted to start our session with this story because this happened in kindergarten, to think about what are all the things that Ava was building upon? What did she know and what did she understand? Like, what was she already making sense of that led her to make this conjecture? So we think about this as sort of falling under maybe 2 buckets, like thinking about the reasoning we saw in Ava's thinking, and also the way she communicated. Because she had communicated in her thinking, right? She represented the expressions 1 plus 9, 2 plus 8, and she organized them in a very particular way with the rows. She wrote the sentence at the bottom or the phrase, there are 11. So she's able to give us insight into her thinking, written language, but she's also used some really useful oral language as she tells us about, I have all the ways backward. And she points when she talks like this. She pointed to 3 plus 7 and 7 plus 3. So she had these really sophisticated ways of communicating to Bethany, to her teacher, but also to the other kids sitting at her table. We can also think about the reasoning evident in what she did, right? She used this structure, as somebody noticed in the chat, like she saw the pattern and she recorded the expressions in a patterned way. She made sense of the commutative property. She even thought about the problem in multiple ways. Like, okay, there are so many ways that the rabbits could be in the hutch and on the grass. So this idea that there can be multiple answers or multiple solutions. So we want to sort of think about like all of the things that Ava was evident in Ava's work. And now we're going to kind of think about, well, what happened before that? What opportunities might Ava have had, or what opportunities can we provide for students to develop some of the skills that we saw evident in Ava's work? So we're going to shift now and talk about an instructional routine. And Sue is going to lead us through the what is the same and what is different to think about what it offers students as they develop reasoning and communication skills.
Yeah, so I want to just invite you all to kind of, first of all, take a look at this image. There's one on the left and one on the right, and you might think that they look the same, but actually they're two different images and they have different arrangements. So take a look. What do you maybe for yourself it's going to be, what do you notice first? And then see what you see that there's the same of and what might be different about these two. And once you have some ideas, maybe you can start the frame as what something that's the same is or something that's different is. You can type that up in the chat so we know what you're referring to. And as we start to get some replies, I'm going to do my best attempt to try to maybe annotate some ideas that might surface some ideas that we can talk about and analyze.
Okay, so Susie's noticed that they both, whoops, it's sliding so fast. They both have 5 blue objects.
But 1 second, sorry. Okay, 5 blue objects that are the same. So I'm assuming it's here. What Susie's talking about. So there's 5 there, and there's 5 there. It's the same.
Yeah, and Dennis noticed the blue 5 is the same. The yellow is different on the left and the right.
Ah, what's different about the yellow and the 5 and then so this 5 right here? And I'm assuming Dennis is meaning this, but it's different because it's missing. This part right
Yeah,
here.
and then also in Dennis's responses, but the total is of everything is still the same. So he's noticing the configurations of the yellow are different. Side is the same.
So we say if we get to a total, it would be, I'm thinking that it's 11 and that there's 11 on this side as well. Okay.
Molly
What
shared
else?
that something that is different is that the one on the left has 1 less.
Oh, okay. So there's 1 less. I'm just going to write here. One less than, is that what she's mentioning or talking about, 1 less on this left side, or did I write that on the wrong one?
The note says something that is different is that the one on the left has 1 less.
Maybe she's talking about here then?
Oh, that could be as well.
Yeah, okay.
So Sarah mentioned that the arrangement of the feet on the pages is different.
So she might be referring to this part, how this part is missing from over here. I guess I can just make it a mark so we can see where it's going. And then this part, what's missing over here? Okay.
And then Tracy's mentioning that the grouping, she used the word grouped. The yellow items are grouped differently.
Items are grouped differently. Interesting. So, meaning there's 5 in a group here. And maybe she sees She said that they're only the yellow ones are grouped differently. Is that what you said, Jody?
Yes, the yellow items are grouped differently.
Okay, so there's 5, and then maybe we can, I don't know, maybe we can call that 6. I'm not sure if that's what she was meaning. 1, and then this one, actually, I should have wrote that this 5 is here. And then this one, it's like 4, and then 2. Okay.
See, the word subitizing has come up a few times. So maybe they're arranged in
Oh,
ways for students to subitize them.
okay. So how would a student subitize like the one on the left? I know that I think it was Susie, or I can't remember the name. She saw that there was 5 here, and then 5, like kids might really pick up, right? They might see that almost like that dice arrangement of the 5 and see that it's 5, 5, and then know that that's one more, and they might call it 11. Sorry, it's
Yeah,
supposed to be an arrow. Okay.
and Dennis actually wrote down, typed in 1 yellow got moved.
Ooh. Yellow. Where did the yellow move that Dennis is talking about? Because it could either be that this yellow moved, right? This yellow moved, got moved. It's kind of hard to annotate this. I don't know if this is what he means, but got moved all the way to, like, it was supposed to be there. Or this
Well, it's
yellow.
interesting because I think
Got moved there.
Marisol's comments might relate to Dennis's because she's saying the yellow in the middle of the 5 is now on the right in the right square. So now there's this language middle and square.
Huh. Nice. So she's seeing it as a square. And you all, I think when Marisol talks about a square, she might be talking about this as the square. Just write it above it. So even when kids are looking at images, right, and using this lens of what's the same and what's different, we found that they use language almost like they're thinking about spatial relations and shapes almost that can help them to lean on that language of shapes and where they see that square to kind of help articulate and come up with an idea or a reason about why they see what they see that's the same or what's different. They, just as some of you all did, they also noticed one more, or the one that's moved over. Well, it's like hard to mute it when you have the annotation tool on. But as we were trying these routines, this very type of routine, we noticed that kids were really just grabbing onto some of these words, such as or quantities like the one less or one more. They noticed that, and almost because those kind of become the structures, right? Like the square is like a structure, or the dominant, like the subitizing and seeing the 5 becomes a structure. And because it's repeated through these images, students started to pick up on that and use those ideas in how they justified their thinking or how they proved or reasoned about their explanation and how they thought about it. So I'm going to clear this drawing, you all.
Sue, I think you're on mute.
Thank you. I'm so sorry about that. Now I'm going to invite you all to kind of think about what we just did in this image routine. Thinking about what was the same or different about about the images. What did that offer you? And what might that offer kids the opportunity to really dig into and think about? So take a moment and then maybe go ahead, and if it has to do with mathematical ideas specific to practices or communication, if you could just lead with that in your chat idea before you write the idea so we know which bucket it would fall under. So Erica is saying that for communication, we could consider equality with different arrangements of numbers. Oh, I'm sorry. The chat's moving a lot faster than I can read, so I melded some ideas here together. So give me a second to catch up. Okay, so let's start with some math ideas. Actually, Lorelai said that we could consider equality with different arrangement of numbers. So being intentional with the amount of objects that we would arrange. In communication, it allows kids to paraphrase another person's thinking and clarify where misunderstandings are. Let's see, and I'm going to put some of these maybe in practices. Carmela is saying it engages them in conversation and problem solving. So that could go into communication or practice. Janet is saying for mathematical practice, model with mathematics. So surfacing some SMPs here. Deborah mentions that for communication, she brings up vocabulary and how to build kids' academic language. That's important. Kind of piggybacks on her saying we need specific vocabulary to make ideas known to others. Susie is bringing up an associative property, the idea of properties that can really be worked and be surfaced in these images. So in mathematical ideas, right? Molly says one of the math practices to construct viable arguments, another SMP coming up here, and critiquing the reasoning of others, right? So two, that comes from SMP 7, right? Viable arguments and critiquing the reasoning of others. It is hard to do in a webinar, Molly, I agree, but I appreciate that you brought that up. It's hard when you feel like you're just talking to yourself, but I'm hoping that people are really thinking about this together in this space. Dennis says precise language. That feels pretty important, Dennis, that kids, even in preschool, right, that level, at an age where they're developing so much and developing language, we want to give them the opportunity to really engage in that precise language and build language around that. Kelly is saying that in mathematical ideas, decomposing and recomposing numbers, that even preschoolers are capable, right? They have the capacity to do these things with numbers, breaking them down and building them back up. That feels pretty critical, but Oh, that's some big math. And that's another thing that these images can really afford kids. So Jody, I don't know if that's a good list for now, but maybe we can share the like, so that obviously not what everybody said, but we try to capture some. Hold on a second.
Sure, I can share my screen now.
All right. So go ahead and just kind of take a look um, at the list that you all kind of came up with to surface the things, mathematical ideas, practices, and communication. That one single image using this lens of same or different offered to us and would offer to students in your classrooms. And again, this list is not exhaustive. You've all added so much, and hopefully you keep thinking about these three elements as you take this work into your classrooms with your students. So now we are actually going to drop into a couple classrooms here. We actually got to try out two of these routines, one of which that you actually did with us right now. And see what you notice kids are thinking about as we unpack their brilliance. Here's Nate.
I noticed this one, there are two squares, and on this one, they're just all combined together. But there is still 8 on this side and 8 on this side.
Wait, how did you know that?
Because 4 plus 4 is 8, and when I was looking at that, I realized, isn't this more? And then I counted these, and then I realized it was 4. It was just this.
Say that again?
When I was doing this, I'm like, this is more than this, and then I realized that there's 4 here but not here, and then I realized when we take this off, it will still be a square, and it makes a square, and it makes it the same as this, so there's still 8.
Oh, because all you would need to do is move this one?
Yeah.
Where would you move that one to?
Yeah.
Nice.
Okay, it goes pretty quickly, but we made some really incredible connections here. And I don't know if you all noticed, and Jody, I don't know if you want to go one slide over. I actually have that image. Might be easier for participants to see it, but
This one?
yeah, so in this one, there's an arrangement where you can really see the structure of the 4 persimmons image. And she finds that same structure in image A. And she comes to this realization that there's 8 in B and that there's also 8 in A. She doesn't have to do any counting. She sees the 4 and 4, she knows that's 8. And then she actually looks at it and realizes, wait, I see the structure of a square. And she concludes she had to do a double look. You can hear it. Well, and then I realized, right, that this was different. And I just had to move one more. And I had to ask her again because she said it so fast. But kids oftentimes will pick up on structures like this that are familiar. They might not know it at first, but they'll discover it in the process, which I think is so brilliant. And that me shows us that she can do here. I don't know if do we have time for the one more, Jody? Okay. So we're going to actually watch Liam now. And Liam is looking at the very image that we all did as a group and as a same and different routine. So let's take a look at how Liam unpacks his brilliance.
This one has 2, and this one doesn't have it in the middle. This one has it's missing, and this is right there.
Which one is missing? Oh, I see. Oh, so there's 2 parts that are missing. Is that something that's the same or is that different?
Different.
So what's the same about these 2 photos?
So this and this,
What about those?
because they both have 5 blues.
They both have 5 blues. And that's something that's the same or different?
The same.
Okay.
So so these are the same. So they all have the same number.
How do you know that?
Because I counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Move? What would you move to make them the same? Ah, if you move that one to the middle here, would that make it the same? Is there another way that you could figure out how many there are here?
5, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Is there another way you could count that if you moved what you were talking about?
The same as this.
How would you, yeah, what would that sound like?
5, 10, 11.
Okay, I love just listening to Liam in the beginning of the video. I don't even know if you noticed. I had to kind of actually count all, right, when he's thinking about. So Liam thinks about quantity a lot of these two images. And I just want to also give some context about me and Liam. They come from 2 different but TK clusters. So they're about 4 or 5 in these videos. And just thinking in these ways where really they're using mathematical ideas, the practices, and communication, right? But Liam goes in, he counts them, and then he starts to notice those patterns, right? And making use of the structures like me was doing. But I don't know if you noticed, he in the first part, he does count them all, right? 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. And he does the same thing to check it. But I'm also seeing as he's explaining to me what he notices, that he sees the structures, and then I ask him again if he is able to count it in a different way, and then he's able to operate on the structures and patterns he notices and says 5, 10, 11, right? So we have some images with these 2 included as well, where we want to give you all some space and time to try these out and talk about them in this deck, and maybe anticipate for yourselves what students might think about, maybe what your students might think about, and say and make connections regarding mathematical ideas, practices, and how they might communicate those things. Okay, so we're going to go ahead and open up breakout rooms. And you all should be able to, you'll be assigned, and then just in your groups, go ahead and try these decks out. And we'll drop that deck in the chat. Apologize, one of my windows closed here. Okay, here we go. So here is the link to the image deck that we want you to go ahead, and then I'm going to go ahead and open all rooms now. Did everyone make it into a room? Looks like it.
It looks like they did.
Okay. And I'm realizing now I didn't give them a time frame that we would be giving them.
We can send them a message. So
We
everyone
can,
sees.
okay. Yeah,
There's a
let's do
message
that.
in the chat. It looks like there's some people that aren't in a room.
Okay.
Okay, I see Dennis. He's saying, I don't think I'm in a room. Which is odd because I can't find his name in the participants list. Erica said she wasn't able to join either.
For those who are having difficulty, do you see any icons on your like Zoom tool bar that says breakout rooms?
No, I'm looking on my list and it says that all participants are pretty much joined and I don't see either Dennis or Erica's name.
Yeah.
Dennis said I had to use a browser instead of Zoom. I was able to open on a Google Doc. Okay.
Yeah, sometimes they'll dismiss the notification, so that might have happened. So I can look for people and try to resend the notification.
Okay, so it looks like Dennis made it. Erica Osborne is still not able to get in.
Okay. For those who are having trouble getting in, I'm trying to resend you a notification through the Zoom app, and it should ask you to join a breakout room.
Oh, on our end or on their end?
It should send it to them.
Okay. It looks like she's been having trouble this entire conference. She said through the whole symposium, I haven't been able to get into rooms. Jody, should we say how many more minutes should we give them? Like 3?
Yeah, maybe like 2 more minutes.
Well, do we have the feature on where it gives them a 1-minute warning when we close rooms? Or does it just bring them back?
It's about like 20 to 30 seconds.
Okay.
Yeah.
That's fine.
It's not a full minute.
As long as it's not like abrupt, sometimes the feature's off and it just goes, warps you right back. Is it till 1 exactly, Jody, or 12:55?
55, 12:55.
Okay, okay.
Yep.
Do you want me to go back to sharing my screen, Jody? You're muted.
Sure, either way, I don't mind either.
Okay. I can share my screen, no problem.
Okay.
Okay. I'll close them at the rooms at 12:51.
Perfect. And then are you going to wrap up something or do we just move to the next? Like, do you want to close that slide up or say anything and then we can move to Ava's?
Yeah, I'll just say like, okay, hopefully that was a time it was helpful for you and that you'll have some opportunities to use this routine in this way. And then back to you, Jody. Dennis is just sharing with us on the chat. I love it. Thanks for following up with them, Naomi.
Of course, yes. Everyone who had issues going into a breakout room, I'm very sorry. I hope you can engage with the chat right now. We will make sure that we have better instructions for our next event when we use breakout rooms.
Okay, I'm going to bring them back. All right, you all, it looks like people are coming back now. I think I just want to give you maybe like 15 seconds to have one thought. What was one thing that you noticed that these images, as you were talking in your groups, afforded you and will afford your students? And just put it into the chat real quick. So people are noticing things about the quantities and colors that kids can talk about, mathematical discourse that it would engage kids. And we're hoping that you can really take some of these ideas back with you and really think deeply about what they, how they could further that talk in your class. So I'm gonna give it back to Jody now.
So we just want to circle back to sort of where we started with Ava's conjecture and this idea that we believe we are conjecturing that doing things like the same and different tasks, that really creates a nice opportunity for young students to develop communication skills, reasoning skills, mathematical skills, all of the things that you all notice. So we just want to come back to this idea of this routine as being a really foundational opportunity for kids and for teachers to develop beginning skills that will lead kids into their mathematical future. So we just wanted to sort of wrap up the story. We also have our contact information on the next slide. So if you're interested in trying things and following up with us, we love to engage in this work. And there's also links to some other things around nurturing math curiosity if you teach older grades and are interested in that. So we thank you for joining us this afternoon and look forward to continuing the conversation. And again, love to hear and communicate with you as you begin this work with your students or continue. Thank you.
Just a real quick reference, the bit.ly on top, the right top corner of the screen will take you to the slides that we used today if you needed the reference. And it also contains the link deck that you all were able to engage with during the breakout rooms. Thank you for joining us today.
If you guys are ready, we can end the session.
Sure.